Okay, so we're going to do a short video today on the normal distribution, which is a special case of a continuous probability distribution. This normal distribution is basically the bell curve. You're probably familiar with the famous bell curve, sometimes known as the Gaussian curve. This is a distribution that occurs in nature everywhere. We measure things. If we measured the average IQ of people, we would get a distribution that looks like this. Most people would be somewhere around the average IQ, and then there's the same amount on either side of a normal distribution. So it's not normal with a lowercase n. It's the name of the distribution, the normal distribution. So it is a capital N here for normal distribution. And whenever you see normal distribution, you know you're looking at the bell curve. It might be a thinner bell curve, a wider bell curve. We're always going to draw the same bell curve here. What's going to distinguish these distributions, they will be completely described once you know the mean of a normal distribution and the standard deviation. We're going to use these Greek letters for now for population mean and population standard deviation. Once we know the mean and the standard deviation of a normal distribution, we know everything there is to know about that distribution, and we can answer any probability question about the values in that distribution. This is a quantitative distribution. We're dealing with numbers. And the first thing I want to show you is the notation. And so just like before, when we talked about the uniform distribution, you saw a U here for uniform distribution, and you had the endpoints of the uniform values. Here, when you see this, you're going to see the random variable x is distributed normally with this mean and this standard deviation. So here's an example here. We're just going to use a simple example here. We're going to say our x is distributed normally with a mean of 100 and a standard deviation of 10. Okay, we can draw that here with this bell curve. And to go through the properties again here, it's a continuous distribution. The total area under the curve is 1, just like every other sample space or distribution density curve that we've talked about. And the mean and the standard deviation describe it. So we're going to start with something called the 68, 95, 99, 7 rule. Now, this is an approximation that can only be used in certain situations, but it's a good starting point to look at the normal distribution. So if we take the mean of the distribution, we know the mean is always going to be in the middle because it's a symmetric distribution, meaning the average is in the middle, and we have the same amount of values on either side of that mean. So we draw our bell curve and we put our mean in the middle. And now if we go out, one standard deviation, right? One standard deviation is 10, so 100 plus 10, and then another standard deviation, and another standard deviation to the right of the mean, and 3 standard deviations to the left. So 100 minus 10, minus another 10, minus another 10. We set up this nice approximation for the normal distribution that we call the 68, 95, 99, 7 rule. And what that means is that in any normal distribution, once you're told that it's a normal distribution, you know immediately that approximately and very close, we'll see the exact numbers in a future section when we do normal distributions where this doesn't apply, but this is a very close approximation. And we can say in any normal distribution, the values that fall within the mean and plus and minus 1 standard deviation is about 68% of the values. If we go out to 2 standard deviations, between 80 and 120, so the mean plus 2 standard deviations and the mean minus 2 standard deviations, we know that 95% of the observations fall within that range. If we go out to 3 standard deviations on either side, 100 plus 3 standard deviations, 100 minus 3 standard deviations, then almost all the values are going to fall within that interval, 99.7%. So we can very easily answer questions involving these numbers, but only questions involving an even number of standard deviations away from the mean is where this rule is going to apply. So if I have any probability question about these numbers, okay, greater than 100, between 90 and 110, greater than 120, less than 90, between 70 and 110, all these numbers are an even number of standard deviations away from center, so I can use this approximation. So what we're going to do here is split this up into these parts. Okay, so we can just basically we can cut this up and then add up the pieces together however we need to answer probability questions. All right, so if we know that 68% of the observations fall within these two values, and we know that the distribution is symmetric, which means same on one side of the mean as on the other, then we know that 34% fall within this category here between 110 and 100, and 34% fall within 90 and 100 here. So we'll put that as probabilities, so 0.34 and 0.34, right? If 68% fall within this range, and we know 100 is in the middle, then half of that 68 fall here, half of that 68 fall here. And then we can do the rest, we can do that for the rest of these chunks of the curve, right? If we know that 95% of the observations fall between 80 and 120, and 68% has already been taken up by these two columns here, well, the difference between 68 and 95 is 27%, right? 27% is the difference between 95 and 68. So that 27% is going to be evenly distributed between this area and this area. So now in this area, half of that 27, so we'll say 135, right? That's half of 0.27. And the other half of that 0.27 is here, right? So 68% between these two values, 95% between these two values. If you add all this up, 68 and 27, then we're going to get 95. And we continue for these two. So now 99.7% minus the 95 that has already been taken up here. So again, the difference here is 4.7%. So half of that 4.7% goes here, and half of that 4.7% goes here. So half of 4.7 is going to be 0.235, and the other 0.235 is going to go there. So now we have 99.7. So the rest, the 0.03%, half of that is distributed here, and half of it is over here. So again, converting to a decimal, half of 0.003 and half of 0.003. All right, now if you add all these up, add all these decimals up, you're going to get equal to 1, right? Because 1 is the total area under the curve. So now, using these numbers, I can now answer all of these probability questions pretty easily. Probability that x is greater than 100, well, 100 is right in the middle. So, we can add this to this, to this, to this, or we can just realize that, well, half of the distribution is greater than 100. So I know the probability is 0.5. Between 90 and 110, well, again, that's a very straightforward question, right? It's between plus and minus 1 standard deviation. It's the very name of the rule. We know 68% of the probability, or 0.68, is between 90 and 110. So it gets a little trickier if you're not going strictly plus and minus 1, or plus and minus 2, or plus and minus 3. You have those answers right in front of you. But let's say we want the probability that x is greater than 120. Well, greater than 120 is the area under the curve to the right of 120. So all we got to do is add up this number and this number, right? That's all we got to do. So we add up this number and we add up this number and we see we get 20235 plus 0015. That's going to give us 0250 or 025. So we're just breaking up the bell curve into pieces, and then depending on what question is being asked, we're breaking up and adding those pieces together. Less than 90, so less than 90 is everything to the left of 90. So we're going to add up 135, 0.0235, and 0.0015. So, if you have to go off to the side and do that, you know how to add numbers. 0.135, 0.0235, and 0.0015. We add that up, right? We got a 0 there. So we get a 10, we carry a 1, 2, 5, a 10, we carry a 1, 3, 5, 6, and 1, and we end up with 16, 0.116, 0.16, or 16%. Right, so you break this up and you look at it any way you want, realizing 68, 95, 90, 99, 7 are the plus and minus 1, plus and minus 2, plus and minus 3. And then you use that information to answer any question involving just these numbers, right? If I want to know what's the probability that x is between 72 and 113, I can't use this approximation. We're going to go to tables once we get there. We'll get there soon, but right now we're just going to introduce this distribution and look at this rule as how to find probabilities. So one more here, probability that x is between 70 and 110. Okay. 70 and 110 is the area between 70 and 110. So we're going to add up 0.0235, this area, plus 0.135, plus 0.34, plus 0.34, and that's it, right? So plus 0.34 twice. So we're going to add up those numbers. And of course, you got your calculator to do this. We say 5, 8, 2, 5, 9, 13, carry a 1, 2, 5, 8. So 0.8385. Right? And then any probability question greater than any of these numbers, less than any of these numbers, between any of these two numbers, we can use this rule and this breakup of the bell curve to answer any of those questions. So that is called the 68, 95, 99, 7 rule. And we'll keep this one nice and short. Next video, we will go into probability questions where the numbers involved are not these nice even number of standard deviations away from the mean. See you next time.